Log analysis is a critical aspect of system monitoring and troubleshooting that allows security analysts and IT professionals to gain insights into the operational status of their systems. Logs are the automated recordings generated by computer systems, software, and networking devices. They provide raw data that can be analyzed to detect anomalies, track system performance, and respond to potential security threats. This process of analyzing is crucial for preventing problems and improving how systems work, which ensures high levels of performance and security. In this video, you'll learn about advanced log analysis techniques and how generative AI can be integrated into log analysis. First, let's define what log analysis is and explore why it's important. Log analysis involves the examination of system-generated logs to extract useful information. These logs contain details about the system's runtime operations, including errors, system status messages, and transaction histories. By analyzing logs efficiently, organizations can monitor and troubleshoot proactively by identifying trends and patterns that could indicate deeper issues. Now, let's gain some insight into the capabilities and techniques used in log analysis. Advanced log analysis tools are essential for effective system monitoring and management. They use sophisticated techniques to parse, filter, and interpret vast amounts of data, enhancing their ability to detect issues, predict system behavior, and maintain reliability. Let's briefly explore how these capabilities work in log analysis tools. First, there's pattern recognition. This is where algorithms scan through your log data to detect patterns and anomalies. It helps you quickly spot anything unusual or out of place, saving you from having to manually sift through massive amounts of data. Next, we have trend analysis. This technique uses time series analysis to forecast future behavior based on past data. It's like having a predictive tool that helps you anticipate and prevent potential issues before they occur. Then there's real-time analysis. This is really exciting because it involves complex event processing engines that detect and alert you to issues instantly. It's like having a 24/7 monitoring system that notifies you the moment something goes wrong, allowing for swift action. Finally, correlation analysis links related log entries across different systems. This is incredibly useful for troubleshooting because it helps you connect the dots and see the bigger picture, identifying the root cause of problems more accurately and quickly. These capabilities together make advanced log analysis tools powerful for system monitoring and management, enabling more efficient and proactive handling of IT infrastructure. Now that you're familiar with some of the techniques of log analysis, let's explore how the integration of generative AI technologies represents a significant advancement in how you monitor and troubleshoot systems. By now you know that generative AI is a branch of artificial intelligence that generates content, including text, images, and data models. But how can it be used to transform log analysis? Imagine you are a security analyst at a large enterprise. Recently, you've been alerted to a series of suspicious login attempts that might indicate a potential security threat. Your task is to analyze the logs to identify the source and nature of these login attempts. First, let's set up Microsoft Copilot. Open Microsoft Edge and navigate to the Copilot icon. Make sure you have the necessary permissions to access log files. Typically, these logs are stored in a central logging system, such as Elasticsearch, Splunk, or even text files on servers. Next, gather the relevant log files from your logging system. For this scenario, let's assume the logs are stored in a CSV file named server_logs.csv. Load the logs into Copilot by opening the CSV file in Excel, copying the relevant log data, and pasting it into the Ask Me Anything text box. Now use Copilot for a preliminary analysis. Ask Copilot to summarize the log file by typing, "Copilot, summarize the key activities in this log file." Copilot generates a summary highlighting the most frequent activities and any anomalies detected. Let's review the output. In this instance, Copilot pointed out 16 login attempts in total. Out of those, 8 were successful, while 8 ended up as failed logins. Copilot might also highlight specific details, such as users and IP addresses that were the most active during these login attempts. Pretty neat, right? Let's dig deeper and request Copilot to identify patterns by typing Copilot. Identify any patterns or anomalies in login attempts. Copilot analyzes the data and provides insights into unusual login patterns, such as multiple failed attempts from a specific IP address. Let's explore some patterns and potential anomalies Copilot has found in the log data. Firstly, there are instances of repeated failed logins. For example, user 2 from IP 192.168.1.12 attempted to log in twice and both attempts failed. Similarly, user 1 from IP 192.168.1.10 had a successful login initially, but failed on the second attempt. These could be potential anomalies and might need further investigation. Secondly, the overall success rate of logins is 50%, indicating that 8 out of 16 attempts were successful. This could be considered normal depending on the context, but if this is lower than usual, it might indicate a problem. Lastly, the distribution of login attempts appears to be spread across different users and IP addresses. Notice that no single user or IP address is making an unusually high number of attempts, which could indicate a brute force attack. For a comprehensive analysis, you should use a dedicated log analysis tool or service. Remember, anomalies vary depending on context. What might appear unusual in one system could be considered normal in another. Let's investigate further into anomalies with detailed querying. Request that Copilot filter logs using specific criteria. For example, you could say, Copilot, display all repeated failed login attempts. Copilot filters the data and presents the pertinent entries. Now, let's review the breakdown of repetitive failed login attempts. In this instance, you will identify that user 2 from IP 192.168.1.12 encountered 2 failed login attempts at timestamps 2024-0601 at 8:17:45 and 2024-0601 at 8:25:10. You will also note that user 1 from IP 192.168.1.10 had 1 failed login attempt at the timestamp 2024-0601 at 8:30:25 after a successful login. These repetitive failed attempts could indicate a potential issue with the user's credentials or a possible security concern. It's recommended that these incidents be investigated further. Next, you'll document your findings. You can generate a report using Copilot. Simply type, Copilot, create a report summarizing the suspicious login attempts and identified threats. Copilot compiles the data and analysis into a cohesive report for you. Let's review the report based on the log data provided. Overall, there were 16 login attempts recorded on 2024-0601 from various users and IP addresses. Copilot detected repeated failed logins from user 2 at IP 192.168.1.12, with 2 attempts at 8:17:45 and 8:25:10. Additionally, user 1 from IP 192.168.1.10 had 1 failed login attempt at 8:30:25 after a successful login. The success rate of logins is 50%, with 8 out of 16 attempts being successful. Here you will note that no single user or IP address is making an unusually high number of login attempts. This indicates that there was no unusual activity. Unusual activity indicates a possible brute force attack. This report gives you a clear picture of the potential threats you'll need to investigate further. Finally, to get actionable recommendations, you can ask Copilot to provide suggestions based on the findings. Just type, Copilot, suggest actionable steps to mitigate these threats. Copilot may recommend actions like user awareness and training, implementing account lockouts, and setting up multi-factor authentication, or MFA. Let's review the actionable steps to mitigate the identified threats. To mitigate the identified threats, start by educating users about secure login practices through user awareness and training. Inform users about the importance of secure login practices. Encourage them to use strong, unique passwords and to change them regularly. To enhance security measures, consider implementing an account lockout policy. After a specified number of unsuccessful login attempts, the system can automatically lock the account temporarily, preventing further unauthorized access attempts. When encountering repeated failed login attempts from users like user 1 and user 2, it's crucial to investigate further. These could indicate either a user simply forgetting their password or potentially malicious activity. If needed, reach out to the users to verify their login attempts and ensure the security of their accounts. Monitor the success rate of logins regularly. If you notice a decrease from the usual rate, it could signal a problem. Continuously track this metric and investigate any abrupt fluctuations to maintain system security. Enhance security measures with MFA. Add an extra layer of security by requiring users to provide 2 or more verification factors to access resources such as applications, online accounts, or a VPN. You now have a comprehensive view of actionable measures you can take with the assistance of generative AI to bolster security and mitigate potential threats effectively. In this video, you learned how the convergence of log analysis and generative AI technologies is reshaping system monitoring and troubleshooting. You also gained insight into how advanced log analysis tools are essential for effective system monitoring and management. By automating and enhancing traditional processes, generative AI enables more robust, predictive, and efficient oversight of your operations. As these technologies evolve, they will continue to play a crucial role in maintaining system integrity and security, helping organizations to mitigate risks and to optimize performance in an increasingly complex digital landscape. Security analysts face a relentless flow of data as they protect IT infrastructures from potential threats. In this video, you will gain insight into how integrating generative AI into security log analysis offers a promising avenue to streamline this process, providing an automated approach to detecting and classifying security threats. However, while these technologies present significant advantages, they also come with some limitations that security professionals must navigate. Let's explore streamlining security log analysis with generative AI in more detail. Generative AI can process and analyze vast amounts of log data at a scale and speed not possible by human analysts. This is rooted in the technology's ability to learn from data patterns and generate new data instances. For security log analysis, generative AI algorithms, such as generative adversarial networks, or GANs, and variational autoencoders, or VAEs, can be trained on large data sets of security logs to understand normal and abnormal patterns. One primary application is the automated classification of log data. For example, by training on historical data, a model can learn to categorize events into normal operations, suspicious activities, and definite threats. This classification aids in prioritizing alerts, enabling human analysts to focus on the most critical issues first. For example, let's use Microsoft Copilot to classify a huge log file containing hundreds of entities. You should receive a response classified in the various categories. Another significant application is anomaly detection. Generative AI models can be designed to understand the normal state of an IT environment. By continuously comparing new log data against this baseline, the system can flag anomalies indicative of potential security breaches. This proactive approach is vital in a landscape where threat actors continually evolve their tactics. In this case, you can ask Copilot by typing the question, "Can you help with anomaly detection for these security logs?" You should receive a response showing you the potential anomalies based on the logs you provided. Furthermore, generative AI can enhance the precision of log analysis. By learning from past incidents, it can reduce false positives and negatives, which are common in rule-based systems. This precision helps security systems focus on true threats, improving the efficiency of their response strategies. Now you can try to filter the logs and check only the true positives within the log file by asking Copilot to show us the true threats only. Based on the logs you provided, you should receive a response showing you the entries that could be considered as potential threats. Let's examine how generative AI can enhance predictive capabilities. Beyond reactive measures, generative AI can forecast potential security threats based on trends identified in the log data. By analyzing patterns that occur before past security incidents, these models can predict likely future attempts and suggest preventive measures. This enables a more proactive security posture, potentially reducing the impact of attacks. But how can you integrate generative AI with existing systems? Integrating generative AI into existing security systems often involves feeding it inputs from various sources, such as firewalls, intrusion detection systems, and network traffic logs. The AI model processes this data, identifies anomalies, and classifies them into categories of threats. This integration can be customized to the specific needs of the organization, allowing for tailored security measures. Despite these advantages, generative AI is not without its challenges and limitations in the context of security log analysis. Let's examine some of these limitations in more detail. Firstly, there is a dependence on quality and quantity of data. Generative AI models are only as good as the data they train on. Inadequate or biased training data can lead to models that are ineffective or discriminatory. This issue is particularly relevant in security contexts, where new types of attacks might not be represented in the training data set. As a result, the model might fail to recognize new threats, resulting in false negatives. A further limitation is that security logs analyzed by AI systems can become targets for adversarial attacks. Skilled attackers can create inputs that cause the AI to misclassify or overlook malicious activities. This vulnerability means that continuous updates and retraining of models to recognize and mitigate such tactics is required. This is a process that can be resource-intensive. Additionally, there's transparency and explainability. Generative AI models, especially those based on deep learning, often act as black boxes with decision-making processes that are not transparent. This lack of explainability can be a significant drawback in security settings, where understanding the why behind an alert is as crucial as the alert itself. Analysts need to trust and understand the AI's decisions to take appropriate actions, which is challenging when the reasoning is not clear. Next, there are integration and scalability issues. Integrating generative AI into existing security infrastructure can be challenging. Systems must be designed to handle the outputs from AI models effectively and integrate them into broader security operations. Additionally, as the AI environment grows, the AI system must scale accordingly, which can be technically and financially demanding. And finally, there are regulatory and ethical considerations. As generative AI becomes more prevalent in security operations, it must comply with regulatory standards concerning data privacy and protection. The use of AI in security settings also raises ethical questions, particularly regarding surveillance and the potential for bias in automated decision-making. In this video, you learned how generative AI offers transformative potential for enhancing security log analysis, providing tools that can automate and enhance the detection, classification, and prediction of security threats. However, security professionals must remain vigilant about the limitations of these technologies. By understanding both the strengths and weaknesses of generative AI, they can better integrate these tools into their security strategies, ensuring a robust defense against increasingly sophisticated cyber threats. Imagine a world where your digital defenses are as adaptive and vigilant as the most seasoned cybersecurity expert, tirelessly watching over your systems day and night. Well, you no longer need to imagine, as generative AI is already making our online interactions safer and more secure. Generative AI offers transformative potential in cybersecurity, particularly in detecting and mitigating password attack attempts. It employs sophisticated algorithms to analyze vast amounts of log data, identifying patterns indicative of malicious activity. By automating the detection process, generative AI not only enhances the accuracy of threat identification, but also significantly reduces the time required for security analysts to respond to potential breaches. In this video, you'll learn about the practical implementation of generative AI in cybersecurity, explore how it can detect credential stuffing attacks, and some of the benefits and challenges it brings. First, let's examine generative AI and password attacks. In cybersecurity, generative AI models can simulate various attack scenarios, helping to anticipate and detect real-world threats. Password attacks, including brute force attacks, dictionary attacks, and credential stuffing, exploit weak or reused passwords to gain unauthorized access to systems. Detecting these attacks involves analyzing log data to identify anomalies such as repeated login attempts, unusual login times, and access from unfamiliar locations. The core advantage of using generative AI in log analysis is its ability to process and interpret large data sets quickly and accurately. Traditional log analysis methods rely heavily on manual inspection and predefined rules, which can be time-consuming and prone to human error. Generative AI models, on the other hand, learn from historical data, continuously improving their ability to recognize patterns associated with password attacks. For example, a generative AI model can be trained on logs from a network's authentication systems. It can then identify subtle deviations from normal behavior that might indicate an attack, such as a surge in failed login attempts or the use of previously unseen IP addresses. By automating this process, generative AI accelerates the detection of password attacks and enhances the overall robustness of cybersecurity measures. We briefly touched upon credential stuffing attacks. Now it's time to take a deep dive to learn more. Credential stuffing attacks involve using stolen username-password pairs from breaches to gain access to accounts on different platforms. Generative AI effectively detects such attacks by analyzing login attempt patterns. For example, a financial institution used a generative AI-based system to monitor millions of login attempts daily, identifying suspicious activities like multiple login attempts from the same IP address across different accounts. By correlating these anomalies with known credential stuffing patterns, the system prevented unauthorized access to customer accounts. Logs of these attacks typically show multiple failed login attempts, repeated attempts from a single IP address, and the use of known breached credentials. The uses for generative AI in cybersecurity are many, but it's important to recognize both the benefits and challenges it creates. Let's begin with the benefits. The first key benefit is enhanced accuracy. Generative AI models improve detection by learning from vast data sets and identifying subtle patterns that traditional methods might miss. Additionally, automated analysis enables real-time detection and response, reducing the window of opportunity for attackers. It also provides scalability, as it can handle large volumes of log data, making it suitable for organizations of all sizes. Earlier, you touched on brute force attacks. Now it's time to take a deep dive and learn more. Brute force attacks involve systematically trying all possible combinations of passwords to gain access to accounts. Generative AI effectively detects such attacks by analyzing login attempt patterns. For example, a financial institution used a generative AI-based system to monitor millions of login attempts daily, identifying suspicious activities, like an unusually high number of failed login attempts from the same IP address on a single account. By correlating these anomalies with known brute force patterns, the system prevented unauthorized access to customer accounts. Logs of these attacks typically show a high volume of failed login attempts, repeated attempts from a single IP address, and the use of various combinations of characters as passwords. Now, let's ask Copilot if there's any indication of an attack in the logs we gathered earlier. In this example, Copilot responded that based on the logs you provided, it appears that there are repeated failed login attempts from the same IP address using different usernames. This could potentially be a sign of a brute force attack. Next, let's filter the logs for a more precise output. Ask Copilot to refine the log file displaying suspicious entry logs only. Now, you should be able to review the output from Copilot, which includes all the suspicious activities relating to the failed login from the same IP address. Next, you can ask Copilot to suggest some mitigation actions. What steps can I take to secure my server? Copilot will provide some recommendations. For example, enhance server security, maintain up-to-date operating systems and software with regular patches, enforce strong, unique passwords, and limit login attempts to prevent brute force attacks. However, there are also some challenges to consider. Ensuring the privacy of sensitive log data is crucial when training AI models, requiring techniques such as data anonymization and encryption. Developing and maintaining sophisticated AI models requires significant expertise and resources, with organizations having to invest in training and infrastructure. And finally, generative AI enhances detection capabilities, but can also generate false positives, requiring continuous refinement and analyst feedback to balance detection accuracy. You can now see that in today's cybersecurity landscape, generative AI is the unsung hero, a powerful ally against the ever-present threat of attacks. From identifying suspicious patterns in a sea of log data to thwarting credential stuffing attempts with unmatched precision, this technological marvel is revolutionizing how we safeguard our digital assets. In this video, you learned that organizations can enhance their security posture, reduce response times, and mitigate the risk of unauthorized access by leveraging generative AI's ability to learn from historical data and identify complex patterns. As the threat landscape continues to evolve, generative AI will play an increasingly vital role in cybersecurity and ensuring the integrity of critical systems. Imagine having a digital detective that never sleeps, always on the lookout for cyber crooks trying to sneak into places they shouldn't be. You've seen how generative AI helps with log analysis and stopping password and DDoS attacks. But now let's dive into how it can tackle directory traversal attacks. Directory traversal, or path traversal, is a type of cyber attack where hackers take advantage of weak security checks on file names given by users. The goal is to gain unauthorized access to files and directories stored outside the web root folder, potentially revealing sensitive system files and data. Recent advancements in the field of generative AI provide new opportunities for automating and enhancing the analysis and detection of these sophisticated attacks. Before diving into the application of generative AI, it's crucial to understand the mechanisms of directory traversal attacks. These attacks occur when an attacker manipulates file paths, often using sequences like .. or .. to traverse directories and access files that are not intended to be accessible. For example, an attacker might exploit a vulnerable file inclusion mechanism to access sensitive configuration files, such as /etc/password on a Unix-based system. For example, a typical attack vector may look like this. When working with file paths in different operating systems, it is essential to use Uniform Resource Identifiers, or URIs, to standardize path formats. In Windows, a file path such as c:\users\name\file.txt would be converted to a URI as file://c:/users/name/file.txt. Conversely, in Linux, a file path like /home/name/file.txt would be converted to a URI as file://home/name/file.txt. This ensures compatibility and proper handling of paths across platforms. You can ask Copilot to verify the type of attack evident in the log file. Based on the log file submitted, you can receive a response similar to the one that Copilot has provided here. In this log file, it appears that the system might be facing a directory traversal attack. Generative AI models greatly improve the detection of directory traversal attacks by learning and recognizing complex patterns in large amounts of data. They're better than traditional systems that only look for specific, predefined signs of attack. These models analyze vast amounts of log data to uncover subtle attack indicators, often missed by human analysts, such as suspicious patterns in benign HTTP requests, as a result, improving detection accuracy. Generative AI automates the labor-intensive process of inspecting logs manually, continuously monitoring and analyzing logs in real time to allow quicker and more efficient responses from security teams. This automation enables the parsing and analysis of millions of log entries instantaneously, particularly during high-traffic events. Additionally, generative AI models can adapt to emerging cyber threats by being continuously trained on new data, maintaining their effectiveness as attackers change their strategies and develop new methods of encoding directory traversal sequences. Let's review some examples of generative AI in action. Firstly, it can be trained to recognize various encoding schemes used in directory traversal attacks. For example, an attack might use URL encoding, double URL encoding, or even UTF-8 encoding. By learning these patterns, the AI can detect attacks that evade traditional detection methods. URL encoding, also known as percent encoding, involves replacing unsafe ASCII characters with a percent sign followed by 2 hexadecimal digits, which represent the character's ASCII code, making it crucial for AI to decode and analyze these sequences effectively. Next, it can be used in identifying complex attack chains. Attackers often combine directory traversal with other exploits, such as file inclusion or remote code execution. A generative AI model can analyze the sequence of log events to identify these complex attack chains. For example, a series of requests attempting to access /etc/password followed by attempts to execute commands can be flagged as a multi-stage attack. And finally, there's correlating across multiple logs. In large environments, attack traces might be spread across different log files, such as web server logs, application logs, and network logs. Generative AI can correlate events across these logs to provide a comprehensive view of an attack. For example, it might correlate a suspicious URL request in a web server log with an unusual process creation event in a system log, indicating a successful exploitation attempt. By using the advanced capabilities of generative AI, organizations can significantly enhance their ability to detect, analyze, and respond to directory traversal attacks, ultimately strengthening their overall cybersecurity defenses. Now that you have explored some examples of generative AI in action, let's examine the role of Microsoft Copilot for Security, an AI-powered cybersecurity solution designed to enhance the capabilities of security professionals. It provides tailored insights that enable teams to defend at machine speed by leveraging advanced analytics and AI-driven insights. Copilot supports end-to-end scenarios such as incident response, threat hunting, and intelligence analysis, making it a robust tool for cybersecurity operations. Key features of Microsoft Copilot for Security include incident summarization and impact assessment. By automating these tasks, Copilot helps security teams quickly identify and mitigate threats, streamline incident management, and improve overall security posture. It integrates seamlessly across the Microsoft security stack, using an organization's data and existing security infrastructure to provide comprehensive protection. Additionally, Copilot's ability to work natively with Microsoft Sentinel and other security tools ensures that it can analyze data effectively and generate actionable insights. This integration enhances the ability of cybersecurity professionals to proactively detect and respond to threats, ensuring a higher level of security and operational efficiency. As you can see, generative AI is a significant advancement which, when applied to the field of cybersecurity, can reap many benefits when applied to detecting directory traversal attacks. By automating the analysis and detection processes, generative AI enhances accuracy, efficiency, and adaptability in identifying and responding to these threats. Tools like Microsoft Copilot demonstrate this when analyzing complex patterns in large data sets, detecting subtle indicators of attacks, and continuously adapting to evolving threat landscapes. Ultimately, the integration of generative AI into cybersecurity strategies offers organizations a powerful means to fortify their defenses against directory traversal and other cyber threats.